Hey everyone, welcome to yet another episode of my video series on Joshua Bloch's Effective Java, where I take all the items that he has enumerated in this book and expound on them and try and make sense of them. And hopefully, as I make sense of it by sharing and making this video, you too can follow along and try and understand what he's written in this fantastic superlative book. Today, we're going to cover item 4. And of course, like I've done in the previous items, before I get to the item, the crux of the video, I need to go through the proviso and set a few caveats or read out a few caveats, let's say, not really reading out, but just following along on some bullet points that I've listed down here. However, if you've been following along, you could just skip the introduction and move to the item itself. But I need to, every single video, because there may be new viewers, make this proviso or record this bit. I just feel like I have a ethical duty to do so. The first point is this is not a tutorial. That is very, very important. I understand YouTube is just, it's programming heaven. It's tutorial heaven. I mean, you could learn anything, virtually anything off YouTube. And most programming-based videos are sort of how-tos, tutorials, things that we'd miss out on, let's say, by not paying attention in a uni lecture. But this is not a tutorial. This is really, it's a selfish project in many ways. I'm trying to make sense of this book, and I find that it's easier to expound on the matter and sort of think out loud. And that helps me understand. And my hope is that it's a sort of a collective understanding and a collective learning. In no way am I a teacher, absolutely not. And I've said this in the previous items. The more I'm understanding Java and OOP programming in general, I'm coming to the realization that I am far from being an expert. So take whatever I say with a grain of salt and don't treat this video like a tutorial, which means if I make mistakes, please point them out in the comment section down below. I like to think of this as more of a blind leading the blind project or video series where I'm blind too, and ipso facto that I'm making the video, I am sort of leading whoever that's watching this, but I am as equally blind as you are. That's not a pun because I'm wearing glasses. It's just a metaphor. Think of it as a exploratory disquisition. So the best analogy that I've been using in the previous items is what one would see in a typical university tutorial setting where we've got an assignment or some problem statement and all the students get together and try to solve it collectively. That's really what I'm trying to do here. And that means, as I did point it out before, I will inevitably make mistakes. And given that this is, I forgot to zoom into the proviso, apologies, I hope you can read that. And given that this is a programming video, all the code that I've used, some of it is repurposed code from Joshua Bloch's repository itself, the stuff that he's published, that's in fact based on the book. All of that code and the stuff that I've written on my own are available on GitHub. So link to that in the description below. Saying that, let's get to item number 4, which is also from chapter 2. We're still in chapter 2, creating and destroying objects. And item number 4 is enforce non-instantiability with a private constructor. This is the shortest item in the book, and it's very easy to understand. And it's just a page, so this video shouldn't be that complicating. It shouldn't be that complicated, and it should probably be quite quick if I can stick to brevity, which is quite difficult for me because I tend to be long-winded. So the first 2 paragraphs really is sort of an introduction into utility classes that we see in the Java library, in the Java utils library. And a good one that we all probably use is the collections utility class. This right here, which if you scroll through it, of course, it's got a private constructor, but also it's got static member variables and static methods, because really these are the stuff that we're going to use as clients in our code. Just an ancillary point before I read the paragraph from Joshua Bloch. It's quite important to understand this. In fact, using utility classes or putting all these utility methods in one single huge class, putting static methods in one single huge class, isn't a good idea. If you do a bit of Googling and do a bit of research into it, Joshua Block himself, he says it's not always a good idea to use utility classes. But also, I came across this really good blog post. Why can't I talk today? Well, I can't talk in each and every one of these videos. There's something wrong with me. But I came across this really good blog post by, okay, I'm going to butcher this. His name is Wojtek Ruzicka. And I'll leave a link to that down below in the description. He did leave, he wrote the blog post in 2017, and it's well worth the read, especially because he kind of expounds and elucidates as to how using utility classes, or let's say misusing them or abusing them, could be sort of an anti-pattern because it doesn't necessarily sit or follow OOP principles. In fact, I've got a little excerpt from his blog. He says here, avoid utility classes. That's the name of the blog post. And then he states, by the OOP principles, an object should contain both data and a behavior performed over that data. Utility classes are just behavior. All the data are passed as inputs. It is in no way object-oriented. It is more of a procedural way of thinking. So it's good to keep that in mind when using utility classes, but that's sort of an ancillary point. And in the book, Joshua Block states, such utility classes were not designed to be instantiated. An instance would be nonsensical, of course, because really, for instance, this class, the collections class, all it really does is hold a whole bunch of static methods that will be used by a client, where we'll just pass data onto the function. In the absence of explicit constructors, however, the compiler provides a public parameterless default constructor. To use this, to a user, this constructor is indistinguishable, that word, from any other. It is not uncommon to see unintentionally instantiable classes in published APIs, especially in public APIs, because, so again, this is a good example because firstly, Joshua Block himself has written this, but it's also just something that we are all familiar with. This class here, if he didn't explicitly state, or whoever that wrote this code, either Joshua Block or Neil Gafter, if the writer of this code didn't explicitly state that explicitly put this private constructor, when the collections class is used by a client, the JVM or the compiler would think of this as being a public constructor and would instantiate this class and create an object in the heap memory. And that's not something we want, especially from a utility class. And then he continues, attempting to enforce non-instantiability by making a class abstract does not work either. The class can be subclassed. So a subclass, when the class is subclass, let's say there's abstract class A, and we don't explicitly state, well, we don't really need to put a constructor in an abstract class, but let's say we have abstract class A, and then B extends that class, a concrete class. The moment that happens, this is what happens. The class can be subclass and the subclass instantiated. So B can still instantiate itself, and it's a type of the parent class A. So instead of talking about it and trying to conceptualize it, let me show a proper example. There's a utility class here. For a moment, I will get rid of this private constructor. So now this class can be instantiated, and despite it not having any explicit code apropos a constructor, the moment this class is instantiated, it has a public constructor with no args. So then I have a child class here, and this child class can extend the utility class. As a result of that, we have a problem because this class is not going to be instantiated because of the child class. However, if we go back to the utility class, and if we add this private constructor explicitly, if we go back to the child class, it'll throw this error. The IDE will say there is no default constructor available in this class. That's good, which is what we want. Well, it's not really what we want, because this is, after all, a utility class, and it isn't created to be inherited, and that's exactly what Joshua Block states. Um, Furthermore, it misleads the user into thinking the class was designed for inheritance. We don't have to inherit just to prevent it from being, let's say, instantiated. Playing all these games, making it abstract class, none of that. It's useless. It also misleads the client. That's what he's trying to say here, because this utility class wasn't created to be subclassed. So of course, the best solution is to explicitly define a private constructor, as I have done here. And nota bene, as we saw before, this does prevent this utility class from being subclassed because it throws the error there. And that's important to keep in mind. But generally, no one really inherits utility classes because they just hold static methods. He continues, there is, however, a simple idiom to ensure non-instantiability. A default constructor is generated only if a class contains no explicit constructors. So, a class can be made non-instantiable by including a private constructor. That's exactly what we've done here. Now, indeed, you may wonder why line number 11? Why do we need this throw new assertion error? Why not just leave it like that as a private constructor? This is simply due to sometimes programmers making mistakes where I'll just read it off the book. He explains it much clearer than I do. The assertion error, so that's right here, isn't strictly required. That's correct. We can just leave the constructor private and leave the body empty. But it provides insurance in case the constructor is accidentally invoked from within the class. So an example for that would be here. This public static void main method, I'm trying to instantiate this class. What you'll see now is if I run this, it'll throw an error. It will throw a throw new assertion error right there. So even from within the class, we can't instantiate that class. However, if we didn't have this assertion error, throw new assertion error, that would be possible. Someone could do it from within the class. And unfortunately now this class, it lost its non-instantiability property. And then he continues, this idiom is mildly counterintuitive because the constructor is provided expressly so that it cannot be invoked. It is therefore wise to include a comment as shown earlier. So that's what he's done here, line number 9. Oh, this is something we touched on before. As a side effect, the idiom also prevents the class from being subclassed. I did already demonstrate that with this example here. All constructors must evoke a superclass constructor, explicitly or implicitly, and a subclass would have no accessible superclass constructor to invoke. So when this is subclass, this child utility class invokes the constructor of the superclass, and if it's private, that wouldn't happen. That's it. It's simple as that. Few lines of code. As I said, the shortest item. The next item number 4, is a very, very exciting one. I'm really keen to dive deep into this. It is prefer dependency injection to hardwiring resources. Recently, I've been taking a